Let's look at a real world example using a charging process in an Audi e-tron. Okay, the Audi e-tron is a premium electric SUV, no, with a large battery and advanced thermal management. Okay, so what happens when you charge this vehicle at the standard fast chargers? No, that is, it could be this at 50 kilowatts compared to high power charge that it could be this one, the red line, that is 175 kilowatts. No, what the graph shows us? Well, on this chart we see two charging curves. Okay, the blue curve shows the power over time at 50 kilowatts, no? And the power is constant over the time, no? Over the time from the 30% to 100% is constant. The power charging don't change. But what happened at 175 kilowatts power? Well, we could see that at 80% of state of charge, the power decrease. What could we happen here? Why we have this behavior? I'm gonna give you a few seconds to think why is happening now. Okay. Uh, well, if in a previous slides we talk about the balancing. Okay, so balancing take times. So the BMS needs times to make this balancing process. So what happens if we charge the vehicle all time at 175 kilowatts? Well, the BMS don't have enough time to make the balancing process. So in this from 80 to 100, we limitate the charging power in order to have a good balance, a good balancing cells inside our high voltage battery. Okay, this only happen in the charging process. Well, it happens in the discharge process. Well, in this graphic we cannot see that, but also in this chart process we have a limited power in order to not go through 0% of state of charge. Okay, uh, this uh, this behavior have a name. Is we enter in a limp-home mode. Limp-home mode is only when the it's a safety feature in electric vehicle. No, it's not. You might not see it during regular use, but it's you have a critical or something is goes wrong. You can see the limp mode. No, limp mode is gonna decrease the use of power. Okay. So finally, guys, we are gonna see other recharge methods. Okay, just plugging a cable is not the only method to recharge the vehicle. We have another ones. So let's gonna see what other methods we have on the market. So we have the inductive recharge. This is the first other recharge method that we can find. Is a wireless charge. Okay, not application on the market at the moment. Developing applications up to 100 kilowatts of power. No, this inductive recharge could give us a 100 kilowatt of power. No, low types compatible with a multitude of vehicle types. No, and the challenge are the efficiency, positioning, cooling, and safety and cost. Okay, as you know, inductive process are very efficiency. But what happens if you do in the wrong way? Okay, you need for this kind of process, you need to positioning the charger in in the correct place of the vehicle. If not, the charging process is not going to start. Okay, for let's see in another example. For nowadays we have this inductive recharge also in smartphones, in smartwatch. No, with your smartwatch, with your smartphone, you use this inductive recharge, and it's very efficient. But they are smallest things, no, very small things. A vehicle that it could have 2,000 kilograms of weight, so it's very, very big. So this is the first challenge, that is the positioning. Okay, then the efficiency. Well, for example, your vehicle, sorry, your smartphone and the charger are in contact. No, when the inductive is in contact, it's very, very efficiency. But what happened between a vehicle and the charger? Well, the vehicle cannot be in contact with the charger because the vehicle is very, very heavy, and it could break the charger. So you have a very small gap here. This small gap reduces the efficiency of the inductive recharge process. Okay, this is another challenge for this method. And then we have the cooling. Okay, as you know, when you inductive current, the heating that you are creating is also very high. So you are gonna need a very another cooling system just for this inductive component. Okay, so it means that your vehicle needs more space for this component. It's gonna need another cooling system for this component, and the weight is gonna increase. Okay, it's gonna increase. So this is another disadvantages that we can find in this inductive recharge. And then the safety and the cost is very expensive, and well, this is very, very safety because you are not having exposing cables and exposing connectors. Okay, that's the challenges that the inductive recharge has.